know two things at this time. We know if it opens up or down, and we know where the vertex is. With those two pieces of information, we should be able to draw a quick sketch of what we have, and that will tell us how many x-intercepts we have. All right? So step 4 is going to be to find the x-intercepts if you have them. All right? So you don't want to go and you do not want to skip this step. You do not want to do this step. You want to skip this step if you don't have any x-intercepts. Do not waste your time on step 4 if on step 3 you said, oh, I've got no x-intercepts. All right? You just skip this. Now, how do we find the x-intercepts? Well, this is going to be the hardest part. We set the function equal to 0 and solve. And I'm going to put here ... because to do that, it might require factoring or quadratic formula. That's basically the two ways we do this. We either wind up factoring or we do a quadratic formula. So when we get to an example, we'll see where everyone is with this. Everyone here is going to be at a different level in terms of their ability to factor. But you can rest assured, the quadratic formula, you can always use it. So that's at least a fallback for us. All right, so now let me see. Step 5, find the y-intercept. And to find the y-intercept, all you do is plug 0 into the function. Okay? That's different than step 4. Step 4 says you take the entire function and you set it equal to 0. Step 5 says you take 0 and plug it into the function. That's always a very easy step, I guess. Students don't have trouble with step 5. Step 6, sketch it. Okay, so step 6, you're going to put all this information together and you're going to draw a picture. All right? You all ready to do one? Okay. So what I'm going to do here on the side, you've got this down. I'm just going to do a shorthand of this. We're going to see if it opens up or down first, right? Second, we're going to find the vertex. Third, we're going to do a quick sketch. Fourth, x-intercepts if we have them. Fifth, y-intercept. We will have a y-intercept. Sixth, we do a sketch. So that's like the very short summary. Yes, sir?
So whenever you're doing step 2, you said like the example was h would equal 2. So you plug that in, do you make it f of 2 or do you make it f of x equals 2?
f of 2. Yeah, see where it says f of h? That means plug 2 into the function. What the other way would look like this, what you were suggesting or asking. That would, I think that's what you were saying. Do you set it equal to 2 or do you? No, you plug the h in for the x. Okay, here we go. Let's do an example. Let's sketch f of x. Let's start out nice, right? X squared plus 4x minus 5. This is a quadratic function, yes? All right, I like the very first thing, it's not on these steps, but I always like to just write down what's A, what's B, and what's C. So who wants to give me A? 1, okay, someone else give me B. 4, someone else? -5. Okay, there we go. We've got A, B, and C, right? It's the numbers in front of those things, right? The number in front of x squared is 1. The number in front of the x is positive 4. The number by itself is -5. All right, now we go through the process. First step. Does it open up or down? Up, right? This opens up. So I'm going to say, I'm just going to do this. I'm just going to draw like that. And I'm going to put here since A equals 1, which is a positive number, right? It's greater than 0. So I know it opens up, right? The second step is to find the vertex. And this is where we need the formula, right? So we find h first, which the formula was negative b over 2a. So figure out what that is, and then someone can tell me what h is. Negative 2? What do y'all think? Negative 2? So negative b means the opposite of b, right? So we take this 4, we take the opposite of it, which is negative 4. We divide that by 2 times a, but a was 1. So that's what we're doing. And this is just negative 4 over 2. And that's negative 2. Now, to get k, what we're going to do is we're going to take our function and we're going to plug this answer into it. So we talked about this last class, right? Evaluating a function, taking a number and plugging it into a function. So I'm going to go back to my original function, and everywhere I see an x, I'm going to replace it with negative 2. So it's going to look like this. Negative 2 squared plus 4 times negative 2 minus 5. Very important that you understand that when you're squaring this negative 2, right, we're going to get what? What do we get? Positive 4, right? This is negative 2 times negative 2. That gives us positive 4. And then here we get minus 8 and then minus 5. So I think we get negative 9 here. Negative 9. Any questions on that? So we know what h is and we know what k is, right? So I'm gonna actually write the vertex as a point. Remember, this is a point, right? This is the point, negative 2, negative 9. So let me ask, let me pick on somebody here. Who have I not picked on lately? Alexis isn't here, right? There's no Alexis? Alicia? Yeah. Alicia. My question, Alicia, is this point, this vertex, is it the highest or lowest point on the graph? Lowest. Why? Because these are negative? Yeah. Okay, so look, think about it this way. Does this parabola open up or down? This one opens up. Okay, so the vertex is either the lowest or highest point, right? Right. So if it has to look like this must be the lowest point, right? But it's because we know that this parabola will have a vertex down here, which will correspond to the lowest point. Make sense? Okay, so this is the lowest point. I'm just going to put it here. This is the lowest point on the graph, right? That's the lowest point on the graph because it opens up. Okay, so now step 3 is to do a quick sketch, right? A quick sketch. So this is the step that I said that, you know, I do this, other people don't. This quick sketch goes like this. And when I say quick, I mean quick, all right? So this is what I'm doing. Okay, I'm going to go to this point. Negative 2 means I move which way? Left. Down 9 means I move, sorry, negative 9 means I move down 9. So I need to go left 2, down 9. I'm not even going to count. I just know I need to go left and down. Somewhere down here is my vertex, right? Somewhere down there. And which way is this parabola open? Up. What can you tell me then? How many x-intercepts do I have? 2. Do y'all see that? I have 2 x-intercepts. I have to have 2. You see? So this tells me I have 2 x-intercepts. That didn't take too long to determine that, right? Just go left, down, draw a point, use the fact that it opens up, boom, I have 2 x-intercepts. So now, do I want to do step 4 then? Yeah, I have 2 x-intercepts, so I need to do step 4, right? So I have to do step 4. I'll do it right here. So step 4, the x-intercepts, I told you this is the hardest part. you're going to take the function and set it equal to 0. That means you're going to take x squared plus 4x minus 5 and set it equal to 0. And here's where we run into what do you know about factoring and what do you not know about factoring. And so let's just, quick show of hands. And don't feel bad if you don't know how to do it, it's okay. I just need to know, do I need to cover this or not? So how many of you feel like you could factor that by hand just right now? You don't need any guidance on that. No one feels comfortable with that? So this turns into x plus 5 times x minus 1. And nobody feels comfortable that you could do that just like I did. Maybe 1 or 2 of you? 3 maybe? Some, Okay, so since we're not completely comfortable with that step right here, from here to here, since everyone's not completely comfortable, we're going to take a pause, okay? We're gonna time out here, and let's talk about factoring and how you can factor a trinomial. Factoring ax squared plus bx plus c. How do you, so the question is, how do you get that and turn it into two things like this? Okay, that's what factoring is. It's turning that big thing into two things being multiplied. And the question is how to do it, all right? So I want to just tell you right now, what I'm going to show you is like the quickest method I can show you that you can pick up quickly and use that won't take 4 weeks of us practicing. Because to get good at this, to go quickly from here to here mentally, takes a lot of practice. And this class, we just don't have time for that. So this method might seem a little longer, but it sure is better than not knowing what to do, right? And it gives you something, all right? So here's the method. You will take this, you will multiply that number times that number, okay? So you take A and multiply it by C, and you're going to get some number. Let's call this N1, okay? Number 1. This is the first number you're going to get when you multiply A times C, all right? And then what you're going to do is you're going to look at the number B in the middle, okay? And that's going to be your second number. And then what you're going to do is you're going to find two numbers which multiply to be N1 but add to be N2. Okay, so if I write this down, it doesn't make a lot of sense unless I do an example. So I'm going to do a specific example over here to the side. Let's do the one we were doing right here. If I take x squared plus 4x minus 5, the first thing I'm going to do is take the number in front here. What's the number in front? 1. I'm going to multiply that times that. 1 times negative 5 gives me negative 5. All right? That's my first number. Then I'm going to take the number in the middle, which is 4. That'll be my second number, right? I'm just going to say 4 equals 4. So there's my second and my first number. Now, you need to come up with two numbers that multiply to be this, but add up to be this. And this part I can't really help you on. Get a calculator out if you need a calculator. But you've got to come up with two numbers that multiply to be this and add to be this. And so what I like to do when I'm doing this step is just kind of like list out some possibilities, right? Like two numbers that multiply to be negative 5, negative 1 and 5, right? Those two multiply to be negative 5. But when I add them up, I get 4, right? Oh, wait, that works, doesn't it? Okay, so that would work. But I could have done 1 and negative 5, right? Those multiply to be negative 5, but they add up to be negative 4, so that wouldn't work. Right? So those are my two numbers. Once you have these two numbers, this next step is going to be weird, like really weird, all right? Here's what we're going to do. I know it's going to look weird for this first time. What you're going to do now, once you have your two numbers, is you're going to draw two sets of parentheses. You're going to put x here, and I'm leaving a little bit of a space in front of each of the x's. Okay? Then what you're going to do is take -1 and put it here, -1, and then you're going to put, this is a 5, I put +5. Make sense so far? There's one more step. There's one more step. And this is the part that confuses the shit out of everybody. The next thing you're going to do is you're going to take the number in front of x squared, okay? And you're going to put it in front of this and underneath this. Now I know that step looks weird, but trust me, it'll help us in a minute. So I put it in front of this x and underneath this 5. Now does it change anything for this problem? Changes nothing because this number was a 1, right? But if this number is something other than 1, we have to do this step. All right, so since it's a 1, we're done. Our final answer is x minus 1 times x plus 5, which is this. Also, does it matter what order I write these in? Does not, okay? Because multiplication is what we call commutative. You can switch the order and it doesn't change anything. I think we should do another one. Let's do another one, okay? How about this? 2x squared minus 7x plus 3. I want you to factor that. Okay? I'm going to work with you on these. So we take the number in front, multiply the number in the back, that's 6, right? Positive 6. That's the first number. The second number is the number right here. This is -7. Okay, you need two numbers that multiply to be this and add to be this. -6 and -1. -1 and -6 work. Let me list out a bunch of the other ones. 2 and 3 multiply to be 6, right? Let's see, we could do -2 and -3. We could also do 1 and 6, right? Do you agree all of these pairs of numbers multiply to be 6? But only one of them adds up to be -7, and that's this one. Do y'all see that? Here's that critical next step, though. I'm going to write two sets of parentheses. Okay? I'm going to put an x here with the space in front of it, an x here with the space in front of it. I'm going to put my two numbers, -1 and -6. Y'all with me? Now, right now, if you stop here, you're wrong. Okay? This is wrong. And you can tell, just if you had to multiply this out, you do x times x, which would be x squared, right? And look at our original problem, 2x squared. So it's not correct yet. So what I have to do now is I have to take this number in front, 2. Please pay attention to this step. I have to put it in front of here and underneath this. Understand? Now hold on. I can also do it the other way around. I can put it in front of this one and underneath that one. It's my choice. It's your choice. Okay? So would you rather do this, 2 here, 2 under here? Would you rather see that? Or would you rather do, which one of these looks better to you? Put the 2 here and the 2 there. Which one do you like, 1 or 2? 1, why 1? Why do you like 1? It doesn't have fractions. 6 divided by 2 will be 3. This right here will leave you with a half. This is still correct though, okay? This is not wrong. But it just, it prefer to not have fractions. So what I'm going to do is this one. So my final answer would be 2x minus 1 times x minus 3. There we go. That's the factored form.
So for the second one, would you just write out the
x minus a half, yeah. You just write x minus a half, that's it. Okay, got it? Have any of y'all ever seen this thing with this weird putting it here? You have seen that short where you put this here and under here?
Oh, no, I
You haven't seen? Oh, you have a question? Okay, I'm sorry.
do we still put equal
Yeah, okay, so this right now is just how to factor this. When we come back over here and set it, we will set it equal to 0 over here. I'm just showing you how to factor in general. Good question. Okay, that makes sense? Should I prove to you that this works or no? Look, okay, just in case you don't believe it, here to here gives you 2x squared, right? Here to here gives you what? Negative 6x. Here to here gives you negative x, and here to here gives you positive 3. And if you put those together, you'll get 2x squared. Put those together, minus 7x plus 3, right? Now, this one works as well. If I go here to here, I get 2x squared. Here to here, I get minus 6x, right? And then here to here, you have to take negative 1/2 multiplied by 2x. The 2's cancel and you just get negative x. And then negative 1/2 times negative 6 is a positive, and then half of 6 is 3. So it works. Okay? All right. So from now on, when I'm doing this, in this class, like when we're doing quadratics, when I go from here to here and I break it down, I'm not going to show that step. So if you need to do that, you know, you'll have to go do that. I'm not going to show it though. I'm just going to say, oh, this can go to here, doing that, we move on. That fair? Okay, I hope that was helpful. Let's continue. So we'll unpause now. All right, so once we factor this, the next step is to take each factor and set equal to 0. So that means I'm going to take x plus 5, set it equal to 0, and then I'm going to take the other equation, x minus 1, and set it equal to 0. This is the standard procedure for when you factor something and set it equal to 0. You set each factor equal to 0. These are both linear equations. We should all feel comfortable solving this, right? Getting x by itself. X is negative 5. Here, x is 1, because you would add 1 to both sides. So we have 2 x-intercepts. And didn't we say we would have 2? There they are. How are we doing? Okay. 4 steps done. 5th step. Y-intercept. And for the y-intercept, this is the easy one. All you do is plug 0 into the function. So 0 squared plus 4 times 0 minus 5. Hey, wait a minute. If I plug 0 in to a quadratic in standard form, won't these first 2 always go away? And so that number by itself, won't that always be the y-intercept? It will, but it's not hard to just plug 0 in, right? 0 gone, gone, and then here we get negative 5. So that's our y-intercept. And now we're ready for our 6th and final step, which is to sketch it. Questions? Here we go. So my 6th and final step. Here I want to be somewhat precise with my picture. So now this is where I start looking back at all the work I had. Now there's some things that weren't on here. Remember, it opened up on step 1. On step 2 we got negative 2, negative 9 was the vertex, right? And then step 3 was this. Step 3 was a quick sketch, sorry. Step 4 was that. Step 5, and then we're drawing it, right? So when I'm looking at this, my vertex goes left 2, down 9. So that means I know I need at least 9 this way, right? And then my x-intercept, negative 5, I need to go at least negative 5 that way, 1 that way. And then my y-intercept is at negative 5, so I need to be down at least 5. So putting all that together, I think if I just go 10 each way, we should be able to get the whole graph in here. Let me try it. So I'm going to just go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Doesn't have to be perfect. That's negative 10. This is positive 10. Let's count by 5s. 5, 10, negative 5, negative 10. Okay, got it? So I'm going to start with the very first piece of information, this vertex. And let me draw my picture in red. So negative 2, negative 9. That means I move to the left 2 and down 9, and I put a vertex right there. And I'm going to label the point negative 2, negative 9. Okay, I'm labeling that point for you so you know exactly what it is. The next thing I'm going to do is I'm going to put the x-intercepts, negative 5 and 1. Those are x-intercepts. That's where I hit the x-axis. So negative 5, 1, 2, 3, 4, 5, right here. That is the point negative 5, 0. Remember, it's on the x-axis, so the y-coordinate is 0, isn't it? So to the left 5, don't go up or down. And then I have another one at 1, 0, right? And then a y-intercept of negative 5. So down on my y-axis to here, and that's the point 0, negative 5, right? Because it's on the y-axis, I don't go left or right, so that's 0, down 5. And that's it. We should have everything we need to draw it now. Yes?
Could you draw it without finding the Y-intercept?
You could. You could. You could draw it without the y-intercept. Absolutely.
So does that mean you're able to skip that step from time to time? Or is it-
I'm going to want you to give me the y-intercept because it's not that hard to, I mean, it's the easiest thing out of all of them to get, right? And it does aid in the picture. Because look, the way I'm going to draw this is I have to draw a U, right? Like a nice U-shaped thing. I want you to kind of think about that axis of symmetry, right? We have this axis of symmetry. Your picture needs to look like this U-shaped thing, and it should be symmetric to that dotted line. So I would start by drawing the right side because you actually have 2 points. See how that kind of aids in the picture? Now, very important, I will take off for this. The bottom of this parabola has to be a U, okay? Cannot be a V. It's not a sharp point down there, it's a curve to it, right? So you want to do a little like curve here like this, and then you want to join up this point, and then just an arrow that implies it just keeps going that way forever. And then you just try your best to make a mirror image of this. It doesn't have to be perfect. That's what I'm looking for. The things I don't want to see are things like that, right? Like that doesn't look like a U, right? I don't want to see this. What if when you were doing this, your vertex was here, and what if when you were doing it, your 2 x-intercepts were over here? What would that tell you? You did something wrong, right? Your vertex should be right in the middle of your x-intercepts. The distance from here to here should be the same as here to here, always. So if if your vertex was over here, something's wrong. You're going to have to go back and just double check everything. I think we may have time for one more. Let's try and get one more in, okay? You ready? And y'all see how I labeled this graph? That's the way I want you to label it. I want you to label your vertex, your x-intercepts, and your y-intercepts. Label all the points. That makes it very easy for me to check to see that you did it right. It's hard to get all those correct without doing all the work right. And also, I need to see the work. You can't just use a graphing calculator to give me an answer. Okay, how about this one? See if I can... Okay. 3x squared minus, wait a minute. Yeah, 6x plus 2. There we go. I want to sketch that. Would you like me to give you some time to try it? Yeah? You want to go for it? Why don't you try it? You got the steps, right? Up or down, vertex. Y'all should have all the formulas written down, yes? See how that goes. I'll be right back. What I'm going to do is while you're doing that, I'm going to start working it. And I'm not going to say anything, I'm just going to work it out. And that way you can look up and see if you're getting the same thing or not, all right?